Hello, I would like to talk about some of the questions that caused some trouble in the second midterm. I think not the whole questions, but maybe a couple of concepts. Anyway, one of the, I think, common errors was this question, especially related with the p-value here and the hypothesis test of this question. Let me first talk about the type of hypothesis test that should have been conducted here. Okay, the government state that mean weight of the active gradient should not exceed 3 milligrams. So for those who cannot remember the question, we had from a factory, two different branches, two different whatever you would like to call, two different batches collected at different days. So from the first branch, we collect a sample of 5 observations, and from the second branch, we collect this sample of 7 observations. And then we would like to test separately whether the first one exceeds 3 milligrams or not, whether the second one exceeds 3 milligrams or not. We are going to do conduct separate tests. I'm going to just concentrate on the second one. So what I would do here is, if I start from the very beginning, I should define a random variable. Let me call the x. X is the random variable. It is, well, actually at least not most, but some of the people still random variable definition is problematic, and I believe definition of random variable, the difficulty here is reflected especially in the last question that I also plan to record a video. Although the definition here may be correct, well, here, of course, the definition in the first question is not related with the second question. Right? They are separate questions, but the concept is problematic. Now, the values that we obtain here are not the random variable. It is the values that the random variable can take. Conceptually, what the random variable here is, whatever you can obtain from the branch 1 in terms of that active gradient. Actually, this should have been not gradient, but ingredient. I'm very sorry for that. Ingredient, whatever. Yeah, so this is, let's say, the mass of, or the weight of active material, I may say, material in branch 1. Weight of active material in a produced, let's say, pill from batch 1 is the definition of X. The English, the wording is not important, at least in this course, it's not important, but the concept itself is important. So these pills are produced so let's say this is batch 1, this is batch 2, two different batches, right? We have all these pills here. Potentially take any pill here and measure the active ingredient here. It is that weight is the random variable X. And for the second one, of course, it's going to be Y. Now, no, you should note that depending on the pill, this X value will change, and that's the nature, of course, of the random variables. It's going to change from observation to observation. So usually we reserve the capital letter X here. I don't give that much importance because it's an introductory course here, but note that this capital X is not these values. It's important to note the distinction. Usually we reserve a lowercase x to denote a sample which consists of some certain observations, for instance, these values. But you could have easily used another word here. Call it A, for instance. 3.07, 3.05, whatever. Here, A will denote the values of X for these specific observations. So here it's going to be a vector of 5 elements. Anyway, here I'm going to, that was more like a part which many people could easily do, but it's more related with, as I said, the third question. For this question, let's define again y is the weight of the pill, the active ingredient in a pill in branch 2, whatever. And my is going to be the population mean of y, which is going to be the average value. Note that this my is not going to be equal to the average of these values. So anyway, so the question here is, the hypothesis test is basically whether my, let me leave here, or whether my, what? Now here these parts are the parts which may cause some trouble. First of all, this part should always be an inequality. Right, so for those who write an equal or smaller sign here, it's problem. Well, this equality may, in its hidden form, may also contain a lower than or a higher than case, but it is shown always as an equality. So here, this is going to be equal to 3 milligrams. That's great. Now, what about this one? Now, what this says is the weight should not exceed 3 milligram, which means it should be 3 milligram or less. If it's 3 milligram, it's okay, it means. Therefore, it separates the whole possible values, a whole possible weight continuum into two. 3 milligrams and less, and more than 3 milligrams. Therefore, equality, since you should always write the equality in this fashion, this is how you should write the hypothesis test. Therefore, here the government specification is buried here, which indeed means, in its hidden form, implicitly it means mu y is smaller equal 3 milligrams, right? But we do not show it with smaller equal, we write it as equal versus the other one. So if you can show this alternative hypothesis is true, then you are going to show that we do not fit to the specifications, to the specs. Now, I don't want to confuse you. You may, under some conditions, if you would like to give a strong conclusion to the specification, you may also write it that way. But note that in this case, the equality is not included in the specifications. So if it were the government specification state that the mean weight of the active ingredient is less than 3 milligrams, if the question were like this with less than statement, then the equality would have been left here again to the null hypothesis. Therefore, it's going to be here, and so this part would have been like this. Again, would have been written with an equality, but would have actually meant mu y is greater than or equal to 3 milligrams, and this would be replaced by less than. But the question should have been should be in this form, is less than. Then you would, when you conclude that this is the case, we would fit to the specifications, right? It would be a strong conclusion, but the equality would be left to the null hypothesis. So usually from the wording here of this question, you can construct an hypothesis test. There is some more subtlety here, but I don't want to too much confuse it. It is at least only from this wording you should be able to come up with a convenient hypothesis test, at least within the scope of this specific course. In reality, this may be a little more complicated, as I said, but it's not something that I would ask. Anyway, so I think, all right, so this is the form that we should come up for this question. Therefore, here, this is hidden, as I said. And if this is the case, we don't fit to the specifications. All right, let me get rid of these parts and continue with the question. So what we would do is we come up with the point estimate here, which is the sample average of these values. And it's going to be, indeed, this is going to be with small y hat, to be much more precise. Y hat is computed as 2.997 milligrams. And for those who rounded it too much as 3.0, please try to use a little bit more significant figures, right? And this is going to be indeed mu y hat, a point estimate of our population mean for y. So the question here is whether mu y is equal to 3 or mu y is greater than 3 milligrams. Now, a problem which I see from most of you is you just try to do the questions a little bit blindly, or just you just concentrate too much on the method. Now, at this point, before anything to do with statistics or anything like this, just use your heuristics. Here somebody says mu y is equal to 3, and somebody says that no, mu y is greater than 3, and I'm going to show you that that guy says. But the sample statistic y hat comes out to be less than 3. So it should be very much unlikely that mu y is greater than 3 milligrams. First of all, this should be the result. Indeed, even at this point, if you are comfortable with everything that we have done, you should immediately see that p-value should be greater than 0.5. So at this moment, without any calculation here, I should realize that, or somebody should realize that, only using these two information, this hypothesis test and the value of y bar, I should come up with this conclusion. What's the exact value is another story, but p-value should be greater than 0.5. So this is what I expect you also from this question. Anyway, now what we are going to do is find the t0 value, because this is basically y hat value, since x values are normal distributed. Y values are normal distributed. Y hat values will be normal distributed. So therefore, and since we do not know the standard deviation, it's going to be t distribution. So 2.997 minus the hypothesized value. So we expect that the null hypothesis is true. Oh, standard deviation of y is found to be equal to 1.5 times 10 to the power minus 3. I'm sorry, this is not standard deviation, this is standard deviation square. So basically, this is variance of y estimate. And this is going to be 1.5 times 10 to the power minus 3. Maybe you could have included another significant figure here, divided by 7 square root. And this whole thing comes out to be equal to minus 203. And the t value with which I'm going to compare it would be t 0.05 with 6 degrees of freedom. So here, if we can take this value, where is that one? 0.05 with 6 degrees of freedom is 1.9 something. All right, and therefore this value, as you can see, what we expect in terms of alternative hypothesis, we would like to exceed this value, but unfortunately, or fortunately, or whatever, 2.03 does not exceed t 0.056 with 1.94. Therefore, specification seems to be obeyed. We conclusion. Now the p-value. All right, let me get rid of this one. Now for p-value, actually what people do is they check this table with this value, and for many of the people what they do is they say that, okay, for 6 degrees of freedom they got this number, so they say that this is p-value is greater than, or some people say that greater than or less than 0.40, but this is, as I said, not understanding the concept of p-value very clearly, because p-value clearly should exceed 0.5. Of course, one can easily say, if one says p-value is greater than 0.4, one can say that, okay, isn't this mathematically correct? Also saying this, of course, it's mathematically correct, but what I expect you for partial grading about p-value of this part is to understand the concept of p-value. So what p-value here is this one. Let me draw in a diagram in a graphical form, and it's an awful line. All right, this is better. So for 6 degrees of freedom, let's say if this is your t distribution, which seems awful, I'll try once more if I can. All right, so here we are with minus 2, 0, 2, 3. We are here at this point. So here for this hypothesis test, p-value is going to be the right-hand side area. First of all, this is what you should understand. If let's say this value come out to be equal to 2.77, I'm just saying, let's say that it were here, then p-value would be here. It's not about the extremeness of this value. We do not decide where the p-value lies, which side of the tail I should take based on the extremeness of this value. It's based on this hypothesis test alone. So here, since the alternative hypothesis is in exceeding direction of the zero value here, zero value corresponds to 3, corresponds to zero value here, right? And I couldn't, yeah. So this line basically corresponds to 3 milligrams. So exceeding 3 milligrams is always this right-hand side area. So wherever your T0 comes about, with p-value is going to be always this area. So I expect you, if you would like to take a full grade from this question, to understand that p-value is the right-hand side area. Here, if this were the lower mu is smaller than 3 milligrams were the alternative hypothesis, then p-value would be here. There, irrespective of the location of T0, it could have been here, 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 whatever, but it's going to be always the left-hand side. And here, this would be the right-hand side. So as I said, due to that reason, p-value, I can easily say that at the very beginning, p-value is greater than 0.5 because it has all the area on the right-hand side, and since t distribution is symmetric, this is the idea. So anyway, so what we can do more than that is, it is minus 265 is also here. Why? Okay, indeed, let me write what it says. Indeed, what the table says here is 0.265 is here, and this area is, this right-hand side area is 0.4. Since this is symmetric, you can do the same thing here. Therefore, it says this symmetric area is also 0.4. Therefore, the right-hand side area here is 0.6. And my value here, therefore, the value that I find is minus 200, minus 0 to 0.203. So let me write it that way. 0 small minus 203, 265. Here, the right-hand side area is 0.6. Here, this is my p-value. And here, the right-hand side area of 0 is 0.5. Therefore, my p-value is going to be between those two. But even if, let's say, this were too difficult, which I don't think it is, at least you should have come up with, if you would like to get a full credit, it's not about the credit, actually, it's understanding the whole idea. If you would like to understand, comprehend the whole idea, you should have easily see p-values greater than 0.5, which I believe, I don't know how many answers. There were none, or maybe 1, 2, I cannot remember exactly. Anyway. So that's all I would like to mention about this question. I think that the 2 points which are important are how to construct a hypothesis test, alternative hypothesis, and how to find the p-value. And actually, this finding the p-value is not confined to T distribution. It's all related with F distribution, whichever distribution you also use. The same logic here applies.